So this is the segment where you discuss about the force displacement diagram, and from that you have to calculate the work. So let us say there is a force versus displacement curve is given. So for that diagram, if I take one small elemental area, so what is this elemental area? If I say dA, so dA is nothing but F into dx. So F is the vertical height and dx is the horizontal height. So corresponding to the dA gives the F dx. That means if I integrate this area, so what I am getting, this integration of area is the total area under the curve. That is nothing but the integration of F dx. Now what F dx means? F dx is the work done. Okay. So that means whenever the force versus displacement diagram is given, so you have to take the area under that particular diagram. So that will give the value of the work. Okay. So area will give the work done. So this area, if I integrate it, so this is the element area dA, that is equal to F into dx. If I integrate it, that means we are getting the total work done. So graphically, area under the force displacement diagram is the work. The total area you have to calculate. Now, whenever I am calculating the area, so area might be positive or it may be negative. If I get the area on the upper half of the diagram, that is on the y first quadrant, so then that area is the positive area. Okay. And if I am getting the area in the negative part of the displacement, that means when that force is negative, so in that situation your work should be negative. So if I want to calculate the total area, so that means you have to add those two area with the sign. So total area gives the total work done. So let us say this area is A1 and this area is A2. Okay. So total work done W net should be equal to how much? W net should be equal to A1 minus A. Why? Because A2 is negative. So that net work done may be positive, may be negative, maybe. It depends on how much amount of area you are getting. Okay. So let us say this situation is there. So here there is a one trapezium, let's say, and you are asked to calculate the work done by the force. So work done by the force means you have to calculate the area. Now what is this area? So this length is 2 meter. This horizontal length is 2 meters. Some of the parallel sides. So one is 2 and another is 4. Okay, so this length is 4 meter. So sum of the parallel sides is how much? 2 plus 4 by 2 into distance between them. Distance between them is the vertical distance, that is 10 Newton. So 10. So that will give the value of answer work. So 6 by 2 means 3. 3 into 10 means 30. So work done becomes 30. Okay. So again I am getting the 30 joule number. That is the positive area because that is the upper part. So if some amount of area comes in the lowermost part, so then that area to be taken to be a negative. So here the entire area is positive, so that means we are taking the work done to be positive. Okay. So let us see this is the situation where the force is given by this variation. This force is variable quantity, and the particle is displaced from x equals to 0 to x equals to 5 meter under the influence of this variable force. So you are asked to calculate the work done. So this is the work done to be calculated in variable work format. That means integration of a dx. Okay, and the limit will be 0 to 5. So 7 minus 2x plus 3x square integration limit is from 0 to 5. So it should be 7 into x minus 2 into x square by 2 plus 3 into x 2 by 3. 0 to 5. So ultimately 7 into 5 minus 5 square plus 5 cube. Okay. So 35 minus 25 plus 125. So 35 minus 25 means 10. So 125 plus 10 is 135. So answer is 135 joule. So that is the work done produced by the variable force while displacing the particle from x equals to 0 to x equals to 5. So similarly, let us say this equation. So the variation of force is given as xi plus y square. This type of variation, and the particle is moved from 1 to 2 to minus 3 to 4. You are asked to calculate the work done. So again, let us say the particle initially, this is the position particle A, and you are moved to particle to the position B. Okay. So that means there is a 2D movement. So your work done should be equals to integration of A dot dA. This is the formula. Now what is the dr number? So for this situation, dr should be dxi. Dr vector is the 2D vector, that is dxi plus dyj. This is the dr vector. So that means xi plus y square j dot dxi plus dyj. Okay, integration. So once I do the dot product, so x square into dx, x square into dx integration plus y square into dy, not x square, so only x. Only x dx is there. So ultimately I am getting these two integration. So for that first integration, you have to put the limit of x because here only the x coordinate is changing. So x coordinate is changing from 1 to minus 3. So here limit should be 1 to minus 3. Then y coordinate is from 2 to 4. Okay. So ultimately it is x square by 2, limit 1 to minus 3 plus y cube by 3, limit 2 to 4. Okay. So ultimately what I am getting, c square means 9 minus 1 square, 1 divided by 2 plus 4 cube minus 2 cube by 3. Okay. So 9 minus 1 means 8 by 2 means 4 plus 64 minus 8 by 3. 64 minus 8 means 56 by 3. So 4 plus 56 by 3 means 56 plus 12 by 3. 68 by 3. So that will be your answer. Okay. So 68 by 3 is the work done. And one of the important fact about this work is that you are displacing the particle from point A to B. Okay. So the force is given as, let us say this is the force vector. F vector is given. Okay. And you are displacing the particle from A to B, but so whatever is the value of force, so in which path you are moving the particle? Let us say I am moving this particle through this path number 1, or I am moving the particle by this path number 2. Is the value of path is dependent. So what is independent of path? So I can conclude that what here is independent of path. Nah. So no information about the path in which I am moving is required. What is independent of path? So this particular force with the amount of work done, which is independent of path. So I don't want to know what is the path in which the particle is moving from point A to. Only information I know that A or B are the two points. Now this is the concept that we have already taught in whenever I have discussed about the constant force. So I know that if the force is constant, then I can say this statement is valid. But here the force is not constant, but still it is valid. Okay, but still it is valid. So there is a particular type of force for which this work done is independent of path, and later on we understand this force has particular name. It's called the conservative. Okay, so this force is known as the conservative. We introduce this, but now we know that this is the kind of force which is known as the conservative force. Why? Because this force is giving a work done which is independent of your path. Okay. Now come to the second situation where I am giving this y square I plus y x square j acting on a particle which is moving along a parabolic path given by this. Okay. So from this to this, so this is the point A and this is the point B. So that means now I am moving the particle from A point origin to point B by a particular path. Path is specified. Now let me check whether the path is required at all or not. So I am moving this particle along this path. Okay. Under the force, that is A vector is given as xy square I plus yx square. This is the variation of the force. Similarly, here also I should take dr vector as dxi plus dyj. Okay. Now what is the work done? So dw should be equals to, or w should be equals to integration of dw. That should be equals to integration of xy square dx plus yx square dy. Okay. Now in the integration both x and y terms are done. So this sort of integration cannot be done until and unless I know the variation of x or variation of y. Now for that situation, the equation of the path is, so I am giving that y equals to x square. So if y equals to x square is given, that means for this situation, what I can write, this integration can be written as x into y square means x square whole square into dx plus second integration has to be changed. Y is equals to x square. So I write y into x square means another y into dy, because there are two equations. One has to be integrated with respect to x, another has to be integrated with respect to y. So whenever I am doing the integration with respect to x, the entire part should be a function of x. But what we found that in this particular situation, the function is both x and y. Here also x and y are there. So in order to replace the x and y separately, I have to use this equation. So whenever I am using this equation, that means now this force is giving the work which is path dependent. I should know in which path I am getting this work. If I move the particle from A to B, let us say through another path. Let us say I am moving this particle through this path. Let us say the equation of this path is somewhat different. Let us say y equals to x cube. Okay. So then our answer will be different. Okay. So this is a path dependent one. So if I integrate it, so it should be x to the power 5 dx, x to the power 5 dx plus y square dy. Now put the limit. So what is the variation? So particle is moving for x equals to 0 to a. 0 to a is the limit for the x and 0 to a square is the limit for the y. Okay. So first is a to the power 6 by 6. I directly put the limit a to the power x to the power 6 by 6 to a to the power 6 by 6 plus y cube by 3. Y cube means a square, whole cube means a to the power 6 by 3. Okay. So that means 3 a to the power 6 by 6. Okay. 3 a to the power 6 by 6 means a to the power 6 by 2. That is the answer. Okay. So this much amount of work you have to do whenever you are moving the particle from point A to B under the action of this type of force. Now this force gives a value of work done which is essentially dependent on path. That means this particular force which gives the work which is dependent on path is called the non-conservative. These are known as the non-conservative force. Okay. So I get the idea about these two types of force. So one is the conservative type of force and one is the non-conservative. Okay. Now let us say I am giving another variation of force, that is yi plus xj. Okay. So the particle is moved from along a straight line. So the path is given from origin to A, comma. So for the first situation, the particle move along this straight line. This is the A point, this is the B point. What is the equation of the path? That is the equation y equals to x. Okay. And second situation is for the second situation, the particle move from 0 to A, comma 0 and then from A to 0 to A in a straight line path. That means, so initially I move along the horizontal direction in this direction. Okay. Then I am moving on the vertical direction. So this is the for the blue path. We are asked to calculate the work done in both the situations. So once I do the calculation for the red path, that means let us say this is the path number 1. So for the path number 1, again the format will remain the same. That is work done should be integration of f dot dr. And I am writing the value of dr as dxi plus dyj. So ultimately what I am getting, y times dx plus x times dy. Again I cannot do the integration. Why? Because with x the y variable is coming. With y the x variable is coming. So I have to replace it. So for that replacement the equation of the path is given. Y equals to x. So what I am doing, so initially x dx plus this can be written y dy. Now I can put the integration limit. That means the x is changing from 0 to a and y is also changing from 0 to a. Okay. So first part is a square by 2. Next part is also a square by 2. Okay. So ultimately I am getting a square cube. So this is the answer for the first part of the problem. That means whenever I am moving the particle along the path number 1. Now I am moving the particle along path number 2 and path number 3. So whenever I am moving along path number 2 and path number 3. So first we calculate the work done for path number 2. That should be equal to integration of a dot dr. Now in this situation what happens? Dr is only along the x direction. No? So f dot dr means I have to write yi plus xj, but dot should be equals to with only dxi. Why? Because the particle moving along the x direction only. Only the I component will be there. So what is the I component? Integration of y dx. Okay, integration of y dx. Okay. But for this path number 2, can I say for this path number 2, y value is 0 everywhere? So that means that if y equals to 0, that means this number becomes 0. So there is no work done for the path number 2. Now come to the path number 3. So for path number 3, work done is along the y direction. So I should write integration of a dot dr, and thus dr vector should be written as a dyj. So yi plus xj dot dyj. Why? Because I am moving along the path number 3, which is vertical line, that means along the y direction. So only I am ready to integration x dy. Okay. Now I know that for the path number 3, at each and every point, the value of x is constant. Now what is the constant? That is a. So simply I can write a times dy. Okay. So a will come out only integration of dy and limit is from 0 to a. So answer is a squared. Okay. So total work done along the path number 2 plus 3 is one part giving 0 work, another part is giving a square joule amount of work. So W net for the entire path so should be equals to a square joule. Okay. So that means you are not getting the same answer for the both part. That means what I can conclude that the work is same, the force is same, force that is acting on the particle is same, but it depends, the work done value depending on which path I am moving. If I am moving along the path number 1 and if I am moving along the path number 2 to 3, so initial position, final position in both the situation are same. But the work is dependent on the path. So that means what you can say over here, this path, work is, this force is also a type of force which is a non-conservative force. Okay, this is also a non-conservative force. Okay, because the work done is dependent on the path. Okay. So similarly, a spring is there whose K is given. How much work will be done by the spring to stretch the spring? Okay. Now you are asked to calculate the work done by the spring. Okay, so you know the work done by the spring is also minus K by 2 into x final square minus x initial square. Okay, so this is the final expression. Now from 10 centimeter from equilibrium. Equilibrium is what? Equilibrium is the neutral position or the null position. That means that equilibrium x is equals to 2. This is the natural length position. Now we are elongating the spring 10 centimeter from equilibrium. So x final is there. So in the first situation, you are elongating the spring 10 centimeter from equilibrium. So let us say the equilibrium position x equals to 0. So you are elongating from x equals to 0 to x final that is equals to 10 centimeter. Okay, that is the situation. So that means it should be equals to minus 200 by 2 into x final square. X final is 10 centimeter. So but you have to take it into a meter because x would be meter situation. So 10 centimeter means 0.1 meter. So 0.1 square minus 0 square. The x initially is 0. So 0.1 square means 1 by 10, 1 by 100. So ultimately it gives minus 1 joule. Okay. Minus 1. In the option B, in the second category, what I am doing, so the spring is elongated from 10 centimeter to 20 centimeter from equilibrium. That means, let us say this is the equilibrium position, x equals to 0. You compress this spring by 10 centimeter. Let us say you are over here x 10 centimeter. Okay, and then elongate it from another 20 centimeter. Got it? So from equilibrium position, initially you are moving towards the left hand direction, so you are getting in this position. And from equilibrium position, again you are moving to the right hand direction by 20 centimeter. So what is the initial position? Initial position was x equals to 0. Then from that, you are getting to 10 centimeter. And so this part is already known. So this part is, we have already, so let us say this is the W1 part, this is the W2 part. Okay, from equilibrium position. So from equilibrium position, x equals to 0, I am moving towards left. So that is the 10 centimeter is the towards left and from initial 0. So that is the first part of the problem. So for this situation, I am getting already minus 1 joule. This is the answer for the W1. Only thing is I have to get the answer for the W2 part. So for W2 part, so again minus 200 by 2. Now the x final square minus x initial square. What is the x final? X final is now 20 centimeter. So minus 200 by 2 into 0.2 whole square minus x initial square is 0 square. Okay. So it is 2 by 100. 2 by 4 by 100 basically. So 4 by 100. So that gives minus 4 joule. No. Minus 4 joule. Got it? Yes, sir. Minus 4 joule. So these are negative. So total work is minus 4 joule. So minus 4 joule is for the W2 part. A W1 part is not minus 1 joule, that should be plus 1 joule. Why? Because initially you are moving from 10 to 0. Na? You are not moving in this direction, you are moving in this direction. Right. Right. Okay. So it should be plus 1 joule. So once it's plus 1 joule, minus 4 joule. So total work is minus 4 plus 1 means W net should be equals to minus 3 joule. Okay, this is the answer. So this is how you have to solve this. Okay. So I am lifting this. So now another question is there. So force is again a variable force. Force is again a variable force. Now you are asked to calculate the work done in moving the object from x equals to 0 to 3x naught by plotting the fx graph. Okay, so you have to plot the x versus x graph, then you have to do it, not by integration. So how to plot this? So for that, first put the check where the force is 0. So if I put x equals to x naught, so for x equals to x naught, what is the value of x? X should be equals to f naught into x naught by x naught minus 1. That means 0. Okay. So I get the idea that at x equals to x naught, at the x equals to x naught, the force is equals to. Okay, so this is the 1 point on the graph. And once I put x equals to 0, so for x equals to 0, what? So once I put x equals to 0, the force should be equals to minus f naught. So the graph will start from here. So this is a minus f naught number. So from here it goes linear and put 3x naught. For 3x naught, once the x equals to 3x naught, I am getting f value equals to 2f naught. 2f naught. So it goes up to this. Okay. So there are 3x naught position and this value is 2f naught. So there are two areas. There are two areas. One area is positive, this area is positive, this area is negative. So what is the positive area? So positive area A plus should be equal to how much? Base is 2x naught. So this distance is 2x naught. Height is 2f naught. So by 2 means 2f naught x naught. This is a positive area. So if I say this is a negative area, base is x naught, height is f naught. So x naught f naught by 2. Negative area. So total work done W net should be equal to how much? 2 f naught x naught minus f naught x naught by 2. Okay, that means 3 by 2 f naught x naught. That is the net. Okay. So you have to plot the diagram and then you have to answer this question. So you have to calculate the area. Once I calculate the area, then one area is positive area and another area is a negative area. So below the x line, that means below the negative y side, at the negative y portion, the area should be on the negative. So that area is negative, the upper part is the positive. So that's why you calculate this. Okay. Now, so with this idea, now we go inside the two types of force that I am discussing, that the conservative and non. So far we got some kind of idea that what is conservative? Conservative forces are those forces for which work done is independent of path. Okay, so path independent. And whenever I want to calculate the work by giving some kind of path information, then that is the non-conservative. Okay, so that is the non-conservative. So before that, I introduce another concept that is called work done by multiple forces. So on a particular body, there may be different types of forces acting. Let us say this is a particle P on which there are different forces that act. So one force is the F1 vector, another force is F2 vector, another is F3 vector. So three types of forces are acting on this particle. Okay, such that F1 is horizontal, F2 is tangential, F3 is always along the directed towards the beam. So these information are given. So that you can plot the vector forces. Okay. So once I plot these vector forces, now I can calculate the work done individually for different parts. So if I want to calculate the individual displacement, so for F1, I have to calculate the work done. So let us say I am getting the work done by W1. For F2, I am getting the work done W2. For F3, I am getting the work done as W3. So since work is scalar quantity, ultimately once I get the total work, that means you have to calculate the work done for each and every individual particle separately. Okay. So you have to calculate the individual work separately and then you have to add this. So whenever the multiple force systems are there, so then what you can do, you can calculate the individual forces and then you can take the component of this. So what is the idea? Idea is that you take individual work done or you can take the entire resultant of all the forces and take the displacement into consideration, then you can calculate the work. Okay. So both are possible. So this is the example of a force situation when the work is being done by multiple forces. So if there is a ring, inside this ring there is a hoop. So let us say the hoop is moving. So hoop is moving down with a velocity v. Okay, because of this velocity, the hoop is experiencing a centripetal force in this direction mv square by r. Okay, there is a weight is acting on this particle mg, and there may be another normal force is there. Okay, so because of this, so there are three forces comes into the picture. Because of this, the three forces comes into the picture. So for each forces, so you have to calculate the work. So in a case where the multiple force systems are there, so you have to calculate that if the particle is experiencing several forces, so whose resultant you can calculate. That is nothing but the vector addition of all the forces. Individual forces are there. Once you take the vector part, you can calculate. So work done by the resultant force F over a certain displacement is nothing but the algebraic sum of the work done by the individual forces over the same displacement. Okay. If I want to calculate the resultant of this force, so once I got the resultant number, so if I displace the particle by let us say dr, I give a displacement of dr. So for that dr displacement, for this resultant force, doing how much I want to work? Can I write integration f dot dr? Okay, there is a total work done. So instead of writing f vector, I can also write the f1 plus f2 plus f2. So that is nothing but the integration of f1 vector plus f2 vector plus f3 vector. All those vectors are there and dr. So that will also give the answer. Okay. So whenever I am giving a multiple types of forces, so first of all I have to calculate the work done by each and every force. Either I can calculate each and every force means you are giving the same displacement. So I am giving the f1 for the f1 force. I am taking dr is the displacement. So what is the work done? Integration of this. For the f2 force, I am giving the same displacement dr. Taken the work done like this, so you can calculate all the work done separately and then you can add this also. Okay. So in both the way I can calculate the work. Okay. Now give the idea of the conservative. So whenever I am saying conservative force, that means in that situation work is independent. Let us say I am moving a particle. I am moving a particle from point A to point B. Okay. So let us say in the situation, the weight is acting downward. Okay. So in order to move the particle, I want to calculate what is the work done by the gravity. So gravity is doing positive work or negative. If I move the particle from A to B, I want to calculate the work done by gravity. Is it positive or negative? Or zero? Which one is correct? It is negative work. Why? Because the index is going upward. So that will negative work. Okay. But we know that whenever the particle is moving and whatever is the path followed, the only thing you have to consider the vertical displacement between point A and B. So for each and every path, can I say the vertical displacement is S? Yes. So that means work done by the gravity is independent of in which direction you are moving, that is immaterial. Only thing is that you have to consider the vertical displacement between the point A and B. And once you know the vertical displacement between point A and B, now you can calculate the work done. Okay. So work done by gravity, or rather I can say gravity force is a kind of conservative force. Okay. Gravity force is a kind of conservative force. So what is the statement? So statement is like this way. So there are three statements are possible. So the force is said to be conservative in nature when the work done by the force is independent of path. That I am telling. Follow between any 2 points. Let us say I am moving the particle from point A to point B by moving either through path number 1 or path number 2 or path number 3. If I get the answer for work done by the particle, work done in moving the particle by path number 1 is same as the path 2 or path 3, then that particular force must be conservative. Okay, then the particular force is conservative in nature. So that is whatever the work that I am getting out of path number 1 or path number 2 or path number 3, so all are equal. So if W1 equals to W2 equals to W3, that means I can conclude finally that is the work is independent of path. Okay, so that means it is a kind of conservative. So this is the first statement. Now second statement is the reverse of this statement. Suppose let us say I am moving along this path number 1 and I am coming back along the path number 2. So if I move along a loop connecting the 2 points, so I am following a loop. So in a closed loop, if I move, if the work done should be. Why? Because work done in moving the particle from A to B, let us say if I say W1, so work done in moving the particle from B to A should be equals to minus W1. If that happens, then it is 0, total 1. Okay, W net is 0. So if instead of moving in defined path, I am choose to move along a closed circular loop, a closed path, closed circular, no, any kind of loop may be there. So along a loop, I am moving from A to B, and again I am coming back from B to A. So if in that situation, total work done if it is 0, then I can say the force is conservative in nature. So that is the second statement. And there is third statement also, that the line integral of the force. So I am moving along the path number 1 or path number 2 or path number 3. So along the 3 different paths I am moving, and I am performing the line integral of the force along the line number 1. Okay. So integration of F dot dl is giving the line integral along the line which is known the path number 1. F dot dl is the line integral along the path number 2. If I get all the results are same, okay, when line integral is independent of the path followed between any 2 points. So these 2 points should be fixed. A and B are 2 fixed points, and you are moving from A to B along a line 1 or line 2 or line 2, and you are performing the line integral. Then that is called the conservative force also. Okay. So these are the 3 definitions of conservative force by which you have to understand which one is conservative and which one is not. So, and the statement is there, line integral along the loop. Okay. If I move along this path and I am coming back to the other path. So line integral along 1 and line integral along 2, if I add those 2, then it should be 0. Okay. So force is conservative in nature when the line integral of a force over a closed path means loop. If it is 0, then also it can be stated as the conservative force. So basic idea behind the conservative force is that the conservative force must be a force which gives path independent. Path independent. So what are the examples of conservative force? First force is the gravitational force. Gravitational force is basically the force of attraction between the two bodies. Okay. So if the particles are M1 and M2 are there, so both are attracting by a gravitational force, and that gravitational force is basically equals to Fg, written as capital G M1 M2 by R. Okay, this is the kind of force that is acting between the two particles, and it is always attractive force. And this force is known as the conservative force. So this is the conservative force, that means the work done by the gravitational force is independent of path. Second is called elastic force. We have already learned this. So elastic force is the kind of force which is conservative force. That means let us say from A point I am moving to B point. So from 0 to B, work done is how much? In this situation, work done for A to B path. If I say work done for A to B should be equal to minus K by 2 into x final square minus x initial square. Now what is x final? X final is x. So minus K by 2 into x square, and x initial is 0. So ultimately I am getting minus K by 2 x square. Now in the same situation, if I move from, let us say, A to C, the C position, I am moving from A to C. A to C means initially at 0, then I am moving to a negative direction, that is compressing the string. So work done moving the particle from A to C, again minus K by 2 x final square minus x initial square. So again x final is how much? X, and x initial is 0. So again I am getting the same answer, minus K by 2 x. That means what I can consider, that work done moving the particle from A to B is same as A to C. Okay. That means it is independent of path. So whatever the situation I am going, so work done is independent. So if I go for a conservative force, then the second example for the conservative force is the elastic force. Is it spring force? Because also conservative force. And third force that we learned in the class 12 topic, that is called the electrostatic force. The force between the two charged particles. So if there are two charged particles, then if their charges are opposite nature, they will feel the attractive force. Okay. If the charge is same nature, then they will feel the repulsive force. So in both the situation, whether it is attractive force or repulsive force, the force is electrostatic in nature, and electrostatic force is also a conservative type of force. Okay. Now the last force, that is the magnetic force. Magnetic force occurs between the two permanent magnet or two electromagnets. So here I am talking about the two magnetic poles. What is the magnetic pole? One is the north pole and the south. So force of attraction between these two is the conservative, or force of repulsion between these two south poles is conservative. Okay. So we understand that in magnetism, there are two types of magnet. One is the permanent magnet and the electromagnet. So force between the electromagnet is not conserved. Force between the two permanent magnet, but it should be magnetic pole. So this is basically the concept. Okay. So another type of force is the central forces. All the forces that passes through the center of the particle, like we know the centripetal force. So centripetal force is there, always centripetal force is always going to be passes through the center of the. So these are called central forces. So force acting along the line joining the center of the two bodies are called the central. Gravitational force, electrostatic force, all are central. And these central forces are must be conservative in nature. They are conservative in nature. So if the forces are central forces, then also it is a conservative. Okay. Like in our solar system, all the particles are moving, and for all the particles, the force of gravity is toward the sun. Nah, whatever the location, the force is always toward the sun. So this is the force of gravity through which they are bounded. So this force is passing to the center of the sun. That means it is a kind of force known as the central force. So if this is a central force, then that means it is a conservative force. Okay. All conservative forces are also central forces, or rather I can say central forces means conservative forces. Okay. Now come to non-conservative. So which does not obey that situation. That means if force is said to non-conservative nature, if the warden is dependent on path. Warden is dependent on path. That means between the initial and the final location is equal. Let us say I am moving the book from point A to point B by path number 1 and path number 2. Now I want to calculate the work done by friction between path number 1 and path number 2. Essentially, path number 2 is the larger path, so work done by friction is more. So work done by friction in path number 2 is greater than the work done by friction in path number 1. So that means the work done by friction is dependent on path. They are not same. They are not same. That means what I can say that friction is a type of force which is non-conservative in nature. So apart from the four forces that have been mentioned, first one is the gravity force, then elastic force, spring force. Third one is the electrostatic force, Fe, and fourth one is the magnetic pole between the two poles. Only poles. So these are the four different forces exist in the universe which are said to be conservative. Apart from all these forces, any other force comes in the picture are non-conservative. So only four typical forces are there which are conservative in nature. Okay. So work done by the kinetic friction is dependent on path. And if I go for the round trip, let us say I'm moving along path number 1 and path number 2. So since the path number 1 is more value, let us say in this path I'm getting 20 joules of negative 1. Friction is going to do the negative 1. Here I am getting the, let us say, my 5 joule of work. Okay. So net work is how much? 20 minus 5. That is not 0. So it should be a non-zero. It should be a non-zero number. Another type of situation is that velocity dependent some forces are there, like air resistance, viscous force. We will learn about these forces in the later part of the syllabus. They are also non-conservative in nature. Okay. There are some forces are there which are proportional to the velocity of the particle. Okay. As the velocity is more, then this force is going to be more. So these forces are also non-conservative in nature. Okay. So these are the variation of the different types of force. Finally, we can conclude the difference between these two forces. So what is conservative and what is non-conservative? That is quite clear to understand. You can read it carefully and you will get it. Right? Okay. So now coming to the how to identify which force is conservative and which force is non. So we already discussed about the 2 or 3 problems where I deal with the conservative and non-conservative. So first format of the conservative force is that the constant force. Why? Because for the constant force, I already know that if the force is said to be constant, then the work done is independent of path. So if a force is given as 2I plus 3J, so 2 is constant number, 3 is also constant number. So certainly this force is entered constant. Okay. Just one second. Yes. So this is called the constant force format. So 2 and 3 both are constant number. Na? So now the particle is displaced from point A to point B and you are said to do the work done. So in this situation, if I displace the particle from point A to B, there is no need to know in which path the particle will move. Why? Because I can simply do the integration. So once I do the integration, so what I write that, so work done should be equals to integration F dot dr. Okay. So F is how much? 2I plus 3J. And integration is how much? dxi plus dyj. Okay. So ultimately what I'm getting 2 times of dx plus 3 times of dy integration. So I know what is the variation of x. X is varying from 0 to 2 and y is varying from 0 to 4. Yeah. So first answer is 2 into 2 and second one is 3 into 4. So 4 plus 12 in 16 joule. Now in order to calculate the 16 joule number, I don't have to know in which direction the part is moving. I only have the identity of A and B point. I should not know what is the path, either it is moving on a straight path or moving along this path or moving along that path. Any path information not required. So can I say this is a constant force format, and whenever the force is constant, then second is the fxfy format. So what is fxfy format? Fxfy format means some component of x should be with I part and some component of y should be with the j part. That means separately x and y components are to be written. Whatever the value can be written. Can I write x cube plus 3x square I? So only x part is there. Then only y, so y square minus 3y, that is there. So that is also a type of format. Okay. If I use the constant force format or the second situation is called the fxfy format, that means here I am putting only x parameter with I, only y parameter with the j, and again the part will displace from 0 to 4. Okay. Let us try to calculate the burden. So dw should be how much? Again f dot dr. So simply write x square dx integration plus y dy integration. So limit from 0 to 4, 0 to 2, and then 0 to 4. Again I am getting x cube by 3 means 2 cube by 3 plus y square by 2 means 4 square by 2. So means 8 by 3 plus 8. So 24 plus 8 means 32. 32 by 3 joule. Again I got the answer, but without knowing the path. So any force that is written in the form of fx and fy format is said to be the conservative. Understood? Now move on to the third format. This is called the perfect differential format. Okay, it's called the perfect differential format. Now what is that format? So now the x and y are mixed with each other. Okay, in the x component, there is not only x and y is there. The second part, x square is there, but no y component is there. It may be there. So for that situation, what you have to do, you have to integrate this component, integrate it. Whether, first of all, you have to check whether you are getting the answer or not. So you have to integrate this number with respect to x. Okay, with respect to x. So I am integrating 2xy with respect to x. So once I am doing this integration, I assume that the y is constant. So I take out 2y outside. So integration of only x dx. Okay. So what I am getting? So 2y into x square by 2. That means ultimately I am getting x square into y. Okay. So, I do the integration for the first part. For the second part again, do the integration. For this part, do the integration with respect to y. But assume that x is now constant, so take x as out. So I take out x square multiplied by dy integration. So integration of dy is y. I am getting the x square y. If these two answers are same, then that particular format is known as the perfect differential. Okay. So this perfect differential format, how to check that? So you have to integrate x component and y component separately. Once you are doing the integration of the x component, you have to integrate with x, but assume that y is constant. Okay. So once you are getting the same result, that means now you ensure that you have the perfect differential. Now what is the work done in this situation? What should be written as integration of d of x square? This is your answer. D of x square. Got it? So in work done is nothing but the d of x square y. What is the x square y? X square is the output that you are getting from this. Okay. So simply d of that. So if I integrate, let us say d of z. So answer is z. So here the answer is also x square y. Okay, this is your answer. So now what is the limit? So you have to put the limit for x square y. So initially the point A is there, point B is there, x is 0, 0, and y is 2, 4. So what is the x square y value at initially? 0 square into y is 0. Okay, 0. What is x square y in the B part? So it should be 4 into 4 in 16. Okay. So I calculate x square y value for the A point and x square y value for the B point separately, and now put the limit from 0 to 16. So answer is 16 then. Okay. 16 will be your answer. So that means this format is also known as a perfect differential format. And how to check it? You have to integrate both the parts. Okay. Let us do this. So I have already integrated it. Once I integrate with dx, so that means you have to take the y to be outside. Once I take out y, so 2y is taken out, so integration of x dx left. So that means I am getting x square by 2. So this means x square into y. Now for this situation, I have to take the x square outside. So once I take out x square dy, so it should be again x square into y. Okay. If these two numbers are same, then we call the perfect differential. Okay. Now in this situation, let us say I am writing 3x square y. So 3x square y square, I have to integrate with respect to x. So for that y square, 3y square should be taken out. Integration of x square dx. X square dx means x cube by 3. So y square into x cube. Okay. And here I am calculating the 2x cube dy. So 2x cube will be taken out. Dy means y only. But these two numbers are not same. These two numbers are not same. So it is not a perfect differential format. Got it? This is not a perfect differential format. So in order to check the perfect differential format, you have to integrate. Okay, let us do it. So if the force is given as a vector equal to 2yi, so now if I want to integrate it, so work done should be equal to integration of 2yi dot dxi. Nah. So ultimately integration will be of 2y dx. Now that integration can only be done. Now that integration can only be done when I move the y as a function of x. I am moving the particle from A to B. In which path I am moving? If I move along the straight path, then let us say y equals to 2x. Then I get one answer. If I move along this path, let us say y equals to e to the power x. Then I get another answer. So depending on the path chosen, let us say I am going to y equals to x cube. Then I got another answer. So every time the value of y is changed, that means you are getting different answer. Nah. So that means what you can conclude, that work done is independent of, not independent of path, it is dependent on path. So that means it is a non-conservative. Okay. Any force which is not in the format 1, 2, or 3, you can categorize it as non-conservative. Okay. Now there is a certain trick to calculate the non-conservative or conservative. So there you have to check whether the force is conservative or not. So for that mathematical formulation, so you have to do the card. What is card? Card is basically a determinant solution. So where you have to a determinant solution. Determinant solution where you are making cross product with this. So this operator is known as the del operator. So del cross A. Now what is the del operator? So del operator is basically written as del x of I plus del y of j plus del z of k. So this is the del operator. Okay. Now here the symbol is known as the del, not the d. So this del operator, so this is basically the del operator. So del. So what is the del meaning? Del meaning is the partial derivative. Here you are doing the partial derivative. What is partial derivative? So which is a partial derivative? Let us say I have a function. Let us say z equals to x cube y square. Okay. So z is the function which is written as x cube y square. Now since z is variable of both x and y, variable in both x and y, I cannot do. If I ask dz dx, I cannot do it. Okay. So instead, what I have to do, I have to do del z del x. Okay. That is not acceptable. I can do this. Now, what is this number? So whenever I have to differentiate partially with respect to x, take the other term constant. So that is y square is constant. Take out. So I can write del x of x cube. Okay. Now simply use the differentiation format that we have learned. So ddx of x cube is 3x square. So your answer should be 3x square y. Okay. Now if I want to calculate del z del y, x cube is common. So del y of y square, that means 2y. So this 2y x. Okay. So this is the partial derivative operator. So you have to do this determinant calculation and check whether this value comes to a 0 or not. If that value comes to a 0, then the force is conservative. If it is non-zero number, then it is non-conservative. Okay. So this is how we have to check it. Okay. Now, in this situation, there are three different forces are acting. Okay. So AB is a quarter of a smooth circular track. So starting from point A to point B. Okay. Point A to point B. So a particle P moves along the track from A to B. So particle moving along the track from A to B and moving the perimeter under the action of three different forces F1, F2 and F3, each of same magnitude A. So what is given? Given is that F1 is always horizontal, F2 is always tangential, and F3 is always directed towards the point B. So these are the three different directions. We were asked to calculate the net work. So net work should be the vector addition or not vector addition. We should net work is nothing but the work done by force F1 plus work done by force 2 plus work done by 3. That is the net work. Okay. Now individually you can calculate. So let us say the particle is displaced. Let us say I am doing the diagram. Let us say the particle is initially at an instant you are saying this is the location of the particle. Let us say theta. Okay. And you displace the particle from this point to this point. Let us say you displace the particle by a small displacement. So let us say this angle is d theta. Okay. So what is the displacement? Displacement is this direction along the tangential direction. Okay. So this number is basically your dr. Got it? So what is this dr? So dr is basically equals to r times d theta. Can I write it? Yes. Dr is r d theta. Okay. So dr is along the tangential direction and that is r times d theta. Very good. Now for the work done, so now individually you identify what are the forces. So for the first force, so let us say I am redrawing this diagram. So this is the theta angle at which if I consider this force, this is the F1. Now, so for that displacement is this direction. This is the dr number for this F1. Now can I tell what is the angle between the force and displacement? Yes. So this angle is also theta. That means this angle is 90 minus theta. Then this is theta. Now, so F1 vector is making an angle theta with the dr vector. Why? Because theta, this is theta, means this vertical angle is theta. That means this angle is 90 minus theta and that other angle is theta. So work done by F1. So for work done by F1, can I write? F1 is constant force. So F dot dr, all are constant. Na? F dot dr. So what is dr? F dr is what? R times d theta into dr is r times d theta and basically angle between them is how much? Angle between cos theta. Cos theta. So this is the integration. So what I am getting that Fr is constant integration of cos theta d theta. Cos theta d theta. Now what is the theta? So at initially theta is 0 degree. Once the particle reaches at point B, the theta becomes 90 degree. So pi by 2. So integration of cos theta is sin theta. So it becomes Fr sin theta, limit is from 0 to pi by 2. So that means sin pi by 2 is 1, sin 0 is 0, means Fr. So first work done, that is the Fr number. Okay. First work done is Fr number. Now come to the second word F2. So F2 is always tangential. So for the F2 is along the direction. So F2 is along dr. So work done by F2 or 2 force, rather I say 2, should be just F2 dot dr integration. Nah. So F2 dot dr means angle is 0 degree. So F2 dr. So what is F2? F2 is F integration of dr only. So what is integration of dr? Integration of dr is total path length AB. Okay. So that is half of the 1/4 of the perimeter. So perimeter is 2 pi r. So 1/4 is pi r by 2. So F into pi r by 2. F into 2 pi r by 4. No? That is the 1/4 of the perimeter. That is A pi r by 2. There is second word done. So first is Fr, then second is A into pi r by 2 and come to the third. So for the third force is directed always towards the B point. This is the B point. Let us say this is the B point. So force is directed towards the B point. In this direction, the force is directed. So if I say that angle is theta, so let us say in this diagram, if I say that angle is theta, so can I say this angle, whatever the angle is there, alpha, this angle is also alpha. Why? Because O, let us say this point is PB is an isosceles triangle. So if that 90 minus 2 alpha plus 90 minus theta equals to 180. Can I write? 2 alpha plus 90 minus theta equals to 180. So that means 2 alpha minus theta equals to how much? 90 degree. Okay. So alpha becomes how much? Alpha becomes 90 degree plus theta. That is the angle alpha. Okay. Now, if I take the component of force, now what is this angle alpha? Alpha is the angle made with the radial direction. Okay. If I take the component, so one component will be along this direction. Now, one component, F3 component will be along this direction. So that component will be F3 cos alpha. Can I take? Yes. Always one component will be directed towards the center, another component will be directed tangential. So what is the tangential component? Tangential component is F3 sin alpha. Okay, F3 sin alpha. So F3 sin alpha is along the dr, but F3 cos alpha is along perpendicular to the dr. So here I am drawing it again. So this is the F3 component which is perpendicular to dr. So this is F3 cos alpha. So F3 cos alpha is always perpendicular to the dr. So that gives the 0 work. Okay, displacement is perpendicular to the force. So only work will be given by the F2 sin component. So work done by third force should be equals to F2 or not F2, F3. F3 sin alpha into dr. So dr is what? Dr is basically our number which is equals to r d theta. That integration. Now F3 is a r taken. Alpha is what? Sine of 90 plus theta by 2. Sine of 90 plus theta whole divided by 2. Can I write it? Yes, this angle, integration of this into d theta. Okay. Now this sine 90, again the limit is from 0 to 90 degree. 0 to 90 degree. Okay. Now this is sine angle. Sine of let us say 90 plus theta by. If I want to integrate it, I have to consider a substitution. Let us say this angle is alpha. So let us say this angle is alpha. Let us say this angle is alpha. So now what I can write, d alpha should be equals to, can I write d theta by 2? This alpha equals to d alpha, d theta by 2. D theta is what? 2d alpha. So ultimately what you can write, that is equals to fr sine of alpha into 2 times of dr. That integration. Now what is the limit of alpha? Limit of alpha, once the theta is 0 degree, so alpha is 45 degree first. Once the theta becomes 90 degree, so 180 by 2 is 90 degree. Got it? So sin alpha d alpha is basically minus cos alpha. Okay. So minus 2 fr into cos alpha. So cos alpha means first one cos 90. Cos 90 is 0. Minus of cos 45 means 1 by root 2. So ultimately what I am getting? Root 2 times fr with a positive sign. So this answer is root 2 times fr. Okay. So this is the third word. So the third number. And I got it. First number is which one? First number is if this one. So this is the first number answer. Okay. And the third one is this number and the second one is this. Now simply add these two. Total burden will be W1 plus W2 plus W3, and once we add the, to take effort to be common. So first number gives the 1, second number gives how much? Pi by 2, and third number gives root 2. So option B will be your answer. Okay. So this is how you have to do this. Be very careful about the work done calculation. So once you are doing the work done calculation, so every time you have to take the analyze the force and the direction in which the displacement is taken. Okay. And accordingly you have to solve it. Okay.